Hello everyone and welcome. My name is Victor Lima. With us today here is Giovanna, my co-host, and this is In Construção, your number one podcast on civil engineering topics. Today we're talking to Professor Rafael Sacks on the topic of BIM and digitalization of the construction sector.
As Victor mentioned, with us today we have the Professor Rafael Sacks, who is a professor of civil engineering at the Technion, Israel Institute of Technology. His researches focus on BIM information modeling, more widely known as BIM, lean construction, and the synergies between them. He is a director of the National Building Research Institute at the Technion and has the Virtual Construction Laboratory. Research projects at the VC Lab include development of BIM-enabled lean production control systems, BIM technology and digital twin construction, say BIM and BIM to twin. He has authored 100 papers in international peer-reviewed journals, 125 conference papers, and numerous book chapters. He is the lead author of the BIM Handbook. Currently is the third edition, and the book Building Lean, Building BIM, Changing Construction in the Tighter Way.
Perfect, amazing. Thank you so much for the introduction. And
that's a little bit more of the professor. So is there something you'd like to tell us about yourself that we haven't mentioned, about your career, your experiences?
Yeah, sure. So I began with a bachelor's degree in civil engineering in Johannesburg, South Africa, at the University of the Witwatersrand. When I was done there, I immigrated to Israel. And not long after, I had the opportunity to study a master's degree in the United States. So I spent some time at MIT in Boston, which I enjoyed very much, doing a master's degree in structural engineering. So it was fairly natural after that to work in structural engineering for a period. So I spent a number of years designing reinforced concrete buildings, mostly residential buildings, high-rise buildings at the time. I then had the opportunity in military service to spend a year in the construction unit, and there I was exposed for the first time to more serious computing in civil engineering, and specifically to using CAD systems from mechanical engineering for modeling the geometries of buildings using mainframe computers. I'm talking about 1989, 1990. And so I made a career change at that time and shifted to preparing software for civil engineering and for architects, mostly then on the back of AutoCAD and AutoCAD version 10 and others in 3D, but nevertheless still CAD software rather than anything more sophisticated. Came a point in time where it became, I won't say boring, but I was intrigued to continue and do a PhD. I left the job and came to the university, the Technion, where I am now for the first time in 1994, and pursued a PhD in construction management, which focused on computing and automation of computing for designing and managing construction. And then, as if I hadn't had enough changes, when I've done with the academic work and the research, I decided to go and work a few more years in construction management directly, and hands-on building buildings for a time. But in 2000, finally, I made my choices and joined the academic world full-time as an assistant professor here at the Technion. And so I've been engaged, I guess now a good 24 years, something, as a full-time academic. But that too has been varied, because I've had the opportunity to spend 2 years at Georgia Tech in Atlanta, working on research on building information modeling with Chuck Eastman and other colleagues. But then after that, a sabbatical I spent at the University of Reading in the UK, and more recently in 2019, 2020, a sabbatical year at the University of Cambridge, where we really began the first steps in digital twin construction. I run the virtual construction lab, and we have master students, PhD students, postdocs who are all engaged in research on building information modeling, on BIM, on lean construction, on digital twin construction, and the research varies from hands-on experiments using the tools to software development to business process aspects, and BIM process as a technology, and BIM people, and so on.
All right, Professor, thank you so much. And you mentioned the use of the CAD softwares, which are pretty much still leading the construction projects in industry as a whole here in Brazil. And I would like to start our conversation with a topic that I notice pretty much everywhere, which is people call 3D modeling BIM without sometimes it being BIM. That's a huge issue that I notice here, even in college or with professionals. Oh, it's BIM, but it's not really. So I would like to start with you telling us a little bit about BIM itself. What is BIM?
Yeah. Well, I'm not a fan of very sharp definitions and distinctions, but I think that there is a key thing here. And the I in the middle between the B and the M stands for the information, and that's the critical thing. With a BIM process, we're compiling all of the information about the project. That is both information about the product, the geometry, the materials, the way that those things come together, and information about the process, meaning construction schedules, plans, supply chain information, and so on. And if we can bring all of that together in a federated model, so federated BIM models consist of architecture, structural engineering, mechanical, HVAC, plumbing, a range of different professional aspects, but also cost estimating, and various other performance analyses like acoustic analysis, energy analyses, lighting analyses, people distribution and movement within buildings, and so on. Then, if we're bringing all that information into a form that we can coordinate across it, and we can check that they match, that the architecture and the structural engineering match, that there are not conflicts between them, and we can test what we're going to do in the computer. And by testing, I mean, can we do a structural analysis? Can we do a lighting analysis? Can we do acoustic analysis? Can we do a mock-up of how the construction itself will work? Can we set up the site organization? Can we do clash checking for physical clashes between objects? Can we fabricate parts of the building off the site and bring them to the site with the knowledge that they will fit, and they'll fit right first time? I mean, if we're coordinating all that information correctly and thoroughly, then we're doing building information modeling. Now, the difference between CAD and BIM is fairly stark. I mean, traditionally and practically speaking, technologies are quite different. CAD is a representational technology where we symbolically represent whatever it is. We prepare drawings of something. And drawings are 2D usually, and they represent something that people can read. Whereas building models are, they're not symbolic representations, they're semantic representations, meaning that the meanings are captured within them and they can be read by computers directly, and they can be manipulated by computers. So if I have an architectural drawing of a facade of a building, that's great, but can I do it without a solar gain analysis? No. It's not the same thing. I can't input that into any kind of solar gain software, so that would not qualify as building information modeling. I'll say one more thing, is that we tend to use the term BIM, and in the BIM handbook we write it this way, that BIM is building information modeling as a verb rather than a noun. And so it's the practice of how we model the building. It's the practice of how we work with the information. Whereas the artifact that we produce is a building model, a digital model of that building.
Excellent. Thank you so much, Professor. I think that clarified many doubts that even I had, and I am sure that some of our viewers had as well. And now, please, Giovanna, for our second question.
Yes, BIM was a technology that was revolutionary to the market when it arrived. And a lot of companies face a lot of challenges, and a lot of professionals as well, on how to adapt. In this era, this digital era, with a lot of innovations and resources that keep popping on, what do you think are the main challenges that the companies are going to face in this era that we are already?
We've observed this in many, many places around the world, and in working closely with companies through research projects. And when I say we, I mean mostly my co-authors, my students, and other professors, and we correspond with all the time. And the common experience, I think, that is most difficult for companies is in making the change, in becoming more digital in their practice, is in preparing the people. The technology can be bought off the shelf, more or less. Yes, it needs to be adapted for different contexts, for different languages, for different things. But the software is fairly well established in various aspects, the modeling software, the analysis software, and so on, cost estimating, project management, common data environments. It's all available, and it's fairly mature. But what companies need to do, whether they be architectural practices, structural engineering consultants, contracting companies, even owners, by owners I mean construction clients, of major clients, they really need to bring their people up to speed to work in a BIM environment. And a BIM environment means we're creating information, and we're exchanging information using building modeling files. That requires an entirely different mindset. So I'm no longer just drawing representations of things and have lots and lots of sets of drawings that represent my mental conception of what we're going to build. But instead, I'm building a 3D model that's usually supplemented with a lot of alphanumeric information. And that representation of my discipline, architecture, structure, something else, should be the only representation of that building for my discipline. We should not have multiple models. We should have a single architectural model, and all the information that we need about that building should be drawn from that model itself only. Yes, we can have versions of the model. We can have version 1, version 2, version 3, but the current version at any time should be the only model that everybody is relating to and working on. Now, for people working in a design office, they'll often say, when they're working with drawings, well, we have this drawing, we have that drawing. They don't necessarily correspond, but different people are working on different drawings, and we have to spend a lot of time coordinating among them. When you move to BIM, that coordination has to be done opposite the model. It can't be done across diverse drawings, and the technology is much less tolerant of mistakes, which is great, because it means we end up with higher quality information. But people need to learn that discipline of working with a model that is common to all, and with maintaining the consistency across the models. And that requires training in software. People need to learn which buttons to press at which time, and so on. But more than that, they need to understand the representations quite differently. So it's really important that when you write table, that you write it correctly, not with spelling errors or wrongly or something else, or lacking, or you forget to put in the information or something. That's a problem. And that discipline is not required when you do drawings. The reason that the people change is so essential, and one of the biggest barriers, is because it costs a lot more than the software. Owners of companies, I think, need to appreciate that when you go through a period of training and change, there's a drop in productivity. So you can expect a certain period of time where you're going to produce less than you did before, and that's the major cost. After that, you're going to raise your productivity well above what you had before, and you'll make it back up. But you need to have the ability in your cash flow, and that's very relevant for smaller offices. You need to be able in your cash flow to survive a period of lower productivity in order to reach a period of much, much greater productivity.
Yeah, that's very interesting, because in fact, you mentioned that sometimes the training is more expensive than the software. And that is really interesting, because you have the technology, you have all that you need. But to learn, you have to spend not just your money, but your time. And time you could be spending in something else.
Yes, that's right. And it means that in the first few weeks or months that you're using the software, you may be less productive than you were with the CAD. And that's a major issue. Managers need to understand that at that point in time, there's a big temptation and a big pressure to go back to the old way. Because I've got to get this thing out next week. I know I can manage it with CAD, but it might take me 2 weeks with BIM. How do I overcome that? And you need to overcome that to work consistently to get over that hump. But when you do, it's downhill after that.
Alrighty. Anything else, Giovanna?
No, I'm just gonna pass the question on to you.
Okay, alright, thank you so much. So, Professor, you've mentioned a lot of the coordination that takes place in construction industry as a whole, and we see that the coordination has undergone significant transformations throughout the years due to the availability of new technologies, the importation of philosophies as well. And we see that methodologies or practices are also taken in consideration, and we have two general ideas that I think correlate a lot, which is building information modeling and the lean construction philosophy. So in this regard, if implemented simultaneously, can we affirm that there are conceptual and practical interactions between the both of them?
Yeah, we can confirm that. We did a lot of exploratory research in this area, especially when I was at the University of Reading. We had a collaboration with colleagues, Lauri Koskela, among them Bargev Dave and others, and we tried to analyze exactly those interactions between BIM technology and processes on the one hand, and the principles of lean construction and lean production on the other hand. For those who wish to look it up, it was published in a paper that came out in 2010 in the Journal of Construction Engineering and Management. And in that paper, we lined up some 24 different lean principles against 18 BIM functionalities. And to, just to pick one out as an example, we have automated generation of drawings and documents as a BIM functionality. And if I cross-reference that with something like reducing cycle times as a principle in lean construction, then that has an obvious interaction. Just to pick out one of the 24 times 18 potential cells in that matrix. When we use building information modeling in its more simple applications, let's say, one of the first things that people learn to do is to produce sets of drawings from the model. And you can do that very quickly, more or less at the press of a button. And once you produce the drawing sets, you often need to go back and and adjust some dimensions and add some text and things like that. But after a while, people get skilled at preparing templates, and you can do it very quickly. You can produce schedules of doors or schedules of rebar or something or things like that very, very fast. And so that means that the overall time you need for any stage of design, architectural design, structural design, even detailing things for production on the construction side, your overall cycle time for doing that is quite reduced. In the lean perspective, reducing cycle time is really critical. We know from Little's law there is a very simple relationship between the amount of work I do at any one time, what's called the amount of work in progress, and the cycle time, the time I need for any individual piece of work. So if in a factory situation we are making a lot of different products, varied kind of products, say making a lot of furniture for kitchens or something. If I'm making a lot of kitchens at the same time, then each kitchen will take a long time. Whereas if I were able to focus on a single kitchen at a time, start it and finish it within a day or two, then I can have very few kitchens under process in my factory, and every day I can do one and send it off. And I need a smaller factory because I only need space for one kitchen. Whereas if I do 10 kitchens at a time and they each take me 10 days, well, the throughput is the same, but I need a factory that's 10 times as big. The same goes for design. So it's very common in engineering, architecture, and other practices to work on many, many projects in parallel. So architects might be working on a house, and they're working on a school, and they're working on something else, and they work on the one that's most urgent at any given time. But also because the cycle times are long, like the kitchens take 10 days, you need the 10 days to work on that project, even though you're not working on it every day in those 10 days. But that means you're working on 10 projects simultaneously. And when you switch from one to the other, you waste time because you have to remember what you did and what they told you and what was happening, what's going on. Oh, and it takes you some time to get back to full speed. Then you work on it, then you put it aside a while again. When you work with BIM, you can say, well, I need to produce this set of drawings. I can do it in a day rather than in 10 days. That means I can be more focused in my work and work on fewer projects simultaneously. So here we have a situation where the greater production rate or productivity or the automation of preparing drawings aligns very well with the principle of lean to reduce work in progress and reduce cycle times so that you have a more rational production. And there are in the table, I'm just looking at it as we speak, we found something like 54 positive interactions. There are also some negative interactions. And there are things like, one of the things that does happen to people is that when you're using building modeling, let's just say, for example, I want to design a kitchen. Since we talked about kitchens, we have kitchens on the mind. I want to put in a set of cupboards. Now, if I'm in very early schematic design, I don't know what kind of cupboards I really want, but it's easy for me to just take from some library a very detailed kitchen cabinet of some dimensions and some size and so on, and put it in. Now, that's over-designed. I've put in much more information than I really should. It would be correct to put in just a box representing that cupboard rather than something terribly detailed. And the danger of that is that when that goes along and presented to clients and they get excited about it and they say, oh, yeah, that's the kitchen I want. The problem with that is that we've rushed to a conclusion without checking alternatives. There might have been other designs for that kitchen that would have worked better. But by virtue of using the building modeling that is so easy to pick up some detailed thing and plop it in, it's as easy as any, I've over-designed too early in the process. So then there is a clear principle in lean construction which suggests you should not overproduce. It's called overproduction. And that's a clear case where BIM tempts you to do that. So there are some negative interactions as well as the positive.
Yeah, I really like this idea of the overproduction and over multitasking not being that effective, because multitasking is essential, but if you don't have a focused tasking as well, focusing a lot on something in order to do many of the same thing, I agree with you, sir. I don't think that things go along quite well. But anyways, Professor, thank you so much. And Giovanna, for the next question.
Well, we talked a lot about how BIM helps us in the everyday tasks at the office, like the ones from projects, and etc. It helps with the management of all the states. It has a cost reduction, increases transparency, increases efficiency, and a lot of various qualities. However, your research talks a lot about the connections between the communication between lean construction and BIM. What do you believe are the best benefits of lean construction? And of its application, not only of its concept.
Well, here again, there are aspects of lean and of BIM that really do work together to achieve what I think is perhaps the most important contribution of lean thinking or lean construction to what we can do in a construction site or in design. But let's talk about the construction site, as you asked. I think that the biggest problem, the biggest root source of waste in construction is that we often send people to do things that are not ready or not thoroughly prepared. or that cannot be done completely as we imagined, or that we provide them with information that's incomplete or inaccurate. And that requires construction crews to either refuse to, or give up what they're doing because they can't pursue it because the information is wrong or there's a clash, or to make things up as they go along, or to improvise in some way. I'll give an example to make this very practical. We might send a team of plumbers to install the piping for some apartment, and they'll come along and they'll find that there are inaccuracies in the concrete bed and the pipes don't fit, and you can't actually connect them in the way that the drawings tell you should connect them. So the toilet is a few centimeters to the left or to the right or higher or lower or forward or backward. And then after that, the carpenters come to fill in, or the tiling people, and it doesn't exactly fit. So you get things that are either they have to stop and find somebody who can explain things to them, or go and look for something. And in the most severe cases, it really cannot be done, so they have to go back to the designers, to the architects or to the plumbing engineers and designers, and say, look, this doesn't work, can you redesign? I mean, this happens a great deal in building systems. You come to install the air conditioning ducts in the plenum of a building, and the ceiling is the depth between the concrete and the false ceiling is too low, so that means that your ducts can't fit in, or the ducts were designed as pipes instead of rectangular or something, and it doesn't fit. And in that case, you may even have to go take the pipes you've brought, or the ducts that you've brought, go back, throw them away, refabricate them, and bring them again. So these kinds of situations where you are not fully prepared correspond to the fact that you haven't taken the time to, what we call in the formal jargon of lean construction, to remove the constraints. So there are 8 classes of constraints. That includes things like the space to work in, the information that we have, the materials, the labor, the equipment, previous work, and so on. And so safe conditions for working and so on. If any of those are not present, then workers cannot really work to their full ability and with full productivity. So we end up with lower productivity, we end up with rework, we end up with mistakes and so forth. The last planner system, as a broad concept, is probably the most significant tool in the toolbox of lean construction, specifically because it lays out a methodology or a method, a sequence of steps to remove those constraints in a proactive, conscious way, where you filter the work and you test it against the requirements and check that it's all mature before you give it to the workers to execute. And if work that's meant to be done is not mature, you don't hand it on. Now, and that can be done at different levels of intensity. There are projects where it's done very thoroughly, following the whole step-by-step procedure. There are projects where it's done in a very superficial way, where they'll have maybe only a weekly work planning meeting, but even that contributes a huge amount to checking that everything is in place, but also to creating coordination across the different trades so that their expectations become clear. Now, the connection between that and BIM is that because building modeling allows you to take control of the quality of the information, it means that both by clash checking, by coordination, by more thorough and more detailed design before you send people to work, it means that the opportunities for mistakes are fewer. It's the probability that you'll end up with contradictions in design or errors in design reduces dramatically when you do virtual design and construction procedures in a construction company, say. So VDC as a practice helps you to generate information that has a higher quality, is more mature, and is less likely to cause all of those problems downstream for the workers when they go out to do that work. And in particular, where you can use VDC to create standards, and when you model one-to-one, dimensionally correct, as to how it will be built, in principle you can remove almost all of the errors and coordination problems. Doesn't say that you've solved. Oh, and I'll add to that it also offers you the opportunity to use that information to pull materials through the supply chain. So if I need to order again, a kitchen cabinet of particular dimensions and color and size and so on, my chances of that coming to the site ready, correct, with the correct holes for pipes and the correct everything else are much, much higher. So I have a much more likely situation where the materials and the equipment will be provided correctly. I hope that answers the question.
It answers it a lot. It's very great to hear from somebody who has so much experience and can give us so much more than we can read off Google. Because what are the benefits of lean construction? Google, okay, fine. But when you talk with someone like yourself, Professor, who has the experience and the knowledge to share it, I don't know, it becomes so much more wholesome, and you can see fully the whole picture. With the examples that you give, I think that's great. I think it clarified a lot for me and for the viewers as well, the benefits of said method. Now we're going to go to question number 5 with Peter.
Alrighty, so thank you so much, both of you. And Professor, now a very focused question. We would like to know a little bit of how researchers are being conducted and all of the consulting being done in Israel. Could you tell us a little bit about what is being done over there?
Sure. I think maybe there are two things that are not different, but special here, perhaps. Overall, our construction industry here is not very different to that in most other places. Broadly speaking, construction is still very labor intensive, it's still very craft oriented, and so on. But increasingly, and I think this is true in many countries, you see that there is a spectrum, let's say. There are the very basic simple construction that people will still do for private homes and for simple projects, even commercial projects and other things that are smaller scale. But when you go up the scale, then you see that we do have very big projects, buildings of 60, 70, 80 stories tall with, 10 basement levels and integration with the metro and the railway and everything else. And we have very big infrastructure projects as well. I think, though, that a more important distinction in most countries is dependent on the sophistication of the client. There is a saying that he who has the 100, in Hebrew it rhymes, but the saying is essentially, he who has the money dictates the policy. And in construction that's true. And so major clients like government ministries or major commercial companies, companies like Walmart or Target in the United States, but airport authorities, highway authorities, companies like these, they generally have professional staff for managing their construction. And the more staff you have and the longer they've been in the game and more experienced they are, the better able they are to create requirements for using building information modeling and for creating BIM mandates. And so we have that here too. And it's only the biggest organizations who have established BIM requirements, BIM mandates, BIM execution plans, and have been able to, I will use the word, coerce the broad community of architects, architectural firms and engineering firms to make that change that we talked about earlier. Essentially, they forced them to make those investments. Because if you want to work with them, you have to work in BIM, and they represent a major part of the market. And so most serious architectural and engineering firms cannot ignore those requirements. And so that has had a big impact on those projects, on those higher end projects. And so we do have some projects where there is very good implementation of building information modeling, but I would not say that that's the majority of the market yet. But it filters through slowly. What we do have in Israel, which is, I think, fairly unique, is that we have a very strong community of construction tech innovation companies. These are startup companies who many times the founders are not necessarily construction people, they're not necessarily civil engineers or architects, although many are, but they're people who come from mechanical engineering, electrical engineering, computer science, a range of business, commercial ventures, and so on. Many of them have been in the military, in the army, especially in the intelligence corps, where they've learned very sophisticated computer applications, technologies for monitoring and things like that. And then they bring that into the world of high tech. And then they're faced with the question, I'd like to create my own company, I'd like to be an innovator, I'd like to have $100 million exit in 10 years' time, that would be great, but how can I do that? And then they look around, and there is so much competition in high tech, financial tech, other areas. So many of them say, oh, what about the construction sector? Well, the construction sector is primitive. They don't know what they're doing. Their degree of digitalization is very low. Here is a field of opportunity. And so we've had in the last, I would say, 10 years, about 200 such startup companies. And many of them fall by the wayside, either because they don't attract venture capital or they don't succeed after some time. But many of them have succeeded, and some have grown very big. And many of them work in the area of monitoring construction, whether using cameras, video cameras, laser scanning, a wide range of technologies, computer vision, image recognition software, deep learning mostly to recognize things, and then they need to map that to the BIM models, because it's only when you compare the project status information, what's actually happening, with the intent information, which is the BIM world, that you can then begin to offer value to construction contractors by saying, you've installed 200 doors so far, but according to the plan, you should have installed by now 250 doors. Clearly you have a problem, you're behind schedule on the carpentry, or something of that kind. So there really is a flourishing. Now, most of those companies, their markets are not here because our construction sector is too small. We have a population of almost 10 million, but they're looking to Europe, they're looking to the US, they're looking to China for the major construction markets. And so there are a number of local construction companies, the bigger companies, who have taken many of these innovative startup companies under their wing, provided them with the ability to use their construction sites as living laboratories, and then to test out, develop their tools for sale and for development around the world. And that's worked very well. Among those, I can think of 3 or 4 big construction companies here who have done that, not on every site, not in every situation, but where it works, it seems to work very well. And also within those select group of construction companies, there is a lot of innovation, both in Lean and in BIM. And so the best of them, Giovanna, you mentioned when you very nicely did the introduction that we have the book called Building Lean, Building BIM, Changing Construction the Tidal Way. That book is about that story of an individual company whose CEO made it his mission to adopt both Lean and BIM in a coordinated way. A lot of successes within the company, a lot of failures along the way, because some things proved to be impractical, but definitely a testing ground. And they also have invested in a number of these venture capital startup companies, and some are becoming very valuable. But certainly they have improved their construction in their company hugely as a result of this interaction.
Well, Professor, thank you so much. And yeah, I think we see the importance of the I in BIM. We see information, but innovation and integration, I think that the I is being very important in this discussion that we're having today. So, Professor, thank you so much. And I would like Giovanna to ask the final question of today's episode.
Yes, so for this question, I would like to remain focused on your personal experience. I would like to talk about your perspective as well. I would like to talk about one of your main bibliographies, that is the BIM Handbook, a guide to building information modeling for owners, managers, architects, engineers, contractors, and fabricators. It talks a lot about the interaction and communication between BIM and Lean construction, but in big projects, such as Sutter Medical Center, Maryland Central Hospital, Hyundai Motor Studios, and Price Mohammed bin Abu Dhabi International Airport. Could you talk a bit about those works and the results of that implementation in that grand scale?
The BIM handbook is a major project that has turned out to have lasted very many years. I mean, the first edition and some of those building projects you mentioned, Giovanna, were in that first edition was published in 2008. So buildings like the Sutter Medical Center were already using BIM then. Projects like the Abu Dhabi Airport and others that you also mentioned, we wrote about in the third edition, which came out in 2018. So even that's already, 6 years ago. And there, of course, the use was far more sophisticated, and it was not being used only for design and for producing construction documents, but it was being used for generative design, comparing design alternatives, and then for managing the construction and for operations and maintenance afterwards. And I believe that most of the examples in the case study there had to do with operations and maintenance. But then there were another 15, 20 odd different projects that we did case studies on in the first, second, and third editions. And it's been interesting to map the progression and the changes in how people have implemented BIM. And the Victor, your emphasis on the letter I, on the information, is very clear, because we see that it's the basis of computer readable information that really is making the changes. That's the thing that when the initial use of BIM sets up, then others can come along after that and exploit that resource, that raw material. And I think that's what's making the change. That's what's also enabling the construction tech. All of those startup companies, they absolutely rely on having computer information to begin with. But I think that, with your permission, Giovanna, I'll try to take that flow of growing sophistication of use of BIM in projects like the Sutter Medical Center, the Mortensen, the Abu Dhabi Airport, and try to extrapolate that a little into the future. We are right now working on the fourth edition of the BIM handbook. The final chapters will be submitted within a week, coincidentally, of our recording of this podcast. So this is the first time we're going to talk to the public about the fact that the fourth edition is about to be launched. It'll be edited and so on. It'll be available, I guess, very early in 2025. But one of the main, and a lot has changed. We've really thoroughly edited the book to bring it up to date, which is a reflection of how much has changed in the industry. And one of the things that we are writing about in the book is a concept called digital twin construction. And digital twin construction is a paradigm where we envision that at some future date, and I don't want to say how long it might take, but that construction on site might become far more, or I'll be precise, that the functions of planning and control of production on a construction site might become far more automated than they are now. Right now, what lean construction has given us is better ways for people to manage the production on the construction site. And what the construction tech companies are giving us are fairly good ways, but increasingly sophisticated ways, to monitor what's going on the construction site and in the supply chain remotely, automatically, and provide that status information. And as long as BIM provides us the intent information, we believe that over time we'll have algorithms that can compare the intent to the status to what was actually done, compare them and make value judgments about what should be done, predict into the future through simulations what we could change in the way we're managing and controlling and what resources we're bringing to the site, and how we coordinate across different construction sites in the same economic area to get much better economies of scale, to reduce waste and so on. And so digital twin construction is a conceptual idea about how we end up with sophisticated software that can fulfill many of those planning and control roles, built on BIM on the one hand and construction technologies on the other hand. And so we see that the impacts that we wrote about in 2008 in the first edition and 2011 in the second, and even in 2018, those impacts appear to be growing, and the potential seems to be growing. As we move ahead in time and things are done, we are able to imagine more and more, and that drives people building software and changing systems and so on. So I think we will see even many more changes in the construction industry in the years to come.
Yeah, as we mentioned before, the market changes really fast, and each time it's changing faster and faster. The number of editions the number of modifications that you said will be in this edition is practically a new book with something that was already established. Yeah.
Which means that there will need to be new translations, and all the work that was done in producing the Portuguese Brazilian edition will need to be redone. You can cut that out of the edit, but it's a conversation I have with the translator. And I will be in Sao Paulo in 2 weeks' time for the BIM conference that is being organized. And so we will have the opportunity to talk about the new Portuguese edition.
And I think the number of changes, it's also a reflex of how the training that the professionals need to undergo to understand the BIM as well. It changes with time. It's a continuous learning process. So it's not an expense, here is a class, pay for the class, it's done, you're learning it well. Nice. Something progressive. And that's right. A lot of companies need to understand that as well. That's not something that you want to learn, you have to learn forever. Because nowadays, that's a concept that I think is not useful anymore, because everything changes constantly, and everything you have to be in constant learning and adaptation.
That's absolutely right. And in many ways, that's the conceptual shift that people need to make, the skills that they need to gain, the ability to deal with change rather than deal with the same old, everyday, same patterns of work, which no longer can compete.
Yeah, and we go all the way back to when you guys mentioned that the training is more expensive than the software. And we go back to learning being not as important as, more important than having the technology, being able to use it correctly in all the integration and getting all the areas of knowledge in one place. So we go back to learning being that important. And Professor, I'm really glad that we had this conversation with you today. It was a pleasure, and I'm sure that it was very informative for me, for Giovanna, and for our listeners. And we would like to give you the floor for a final message for our Brazilian listeners and international listeners.
I don't think there's anything particularly special to say, other than I have found building information modeling to be a very stimulating topic to be dealing with, and particularly in research. I think that the most things I've learned from industry, from working opposite industry, but through the eyes of my students. And so I encourage anyone who has the interest to engage in working with BIM and with Lean, but also to engage in research and exploration of what might come next. It's a wide open field. We haven't even mentioned the applications of AI, of machine learning, deep learning, and so on. A comment would be, Giovanna, you mentioned that some people might say, they might go to Google and say, what are the benefits of BIM? But I suspect that today you would get a better answer from ChatGPT than you would from Google. And that's part of these influences that are influencing the world of construction, the world of BIM, but they run together. You can't imagine querying a set of drawings, CAD drawings using ChatGPT, but you can imagine querying BIM models, even in IFC formats, using those tools, and people have begun doing that. So the imagination is our only limit, I think.
Yeah. Well, thank you so much for the message and for your participation. And for those listening to us that are interested in learning more about innovations in civil construction, listen to our 44th episode with Professor Patricia Tozopoulos, discussing Industry 5.0, learning about the advances of this revolution.
Once again, thank you so much, Professor. And for those who are here with us so far, we'd like you to enter our social medias at inconstrução.ufg to know more about projects being conducted internationally and here in Brazil. And thank you so much, Professor. And guys, see you on our next episodes. This was
Em Construção.
your number one podcast on civil engineering topics. Thank you, Professor.
Thank you.
My pleasure.
Have a great day.
Have a good day.
Alrighty.
Bye-bye.